Hey everybody, welcome back to another not quite so weekly update. First, let's talk about that before we get into things. Like I mentioned the last update, things are progressing still, but they're progressing a lot more kind of in the same general area, so there's not a whole lot to talk about on a week to week basis. So, what I've decided is that I'm going to try making these a monthly update, and we'll see how that goes. If it winds up being too long between updates, then might make it a bi weekly update, or we'll just see how it goes. Now, let's get into what I've been up to for the last month. First off, we've got E1M3's layout finished. Not the entire level done, but that's because I've been working on polishing the first two levels for the Game Development World Championship, or the GDWC. Basically, just a showcase event for indie games so that people can get their hands on them a little bit early and see what they're all about. So just want to make sure that the early game is a little bit more polished and ready to showcase. And in that vein, I've been working on things that will be used in those levels and also that are being used in E1M3. So we're still in E1M3 territory right now with more sprites and materials and adjusted moving walls so that they can now use sprites. So that way I can do things like have a barred gate and have that move like a moving wall. Adjusted player jumping. So this is one of the things that I'm changing for the showcase a little bit. I'm trying to kind of rein in certain mechanics that are gonna, go throughout the entire game, like movement. Trying to make sure that that feels nice. And I noticed that the jumping still felt a little too floaty for me. So after adjusting it, now I think I've got it about where I like it. So I might have to really fine tune it later on, but for now I think it feels pretty good. It's right around where I want it to be. Weapon balance. I had to change up the shotgun a little bit because the shotgun was a little bit much. It was jibbing people from 20 feet away. So what I did was I took away some accuracy from the pellets, so I just spread out the pellets a little bit more, and that seems to have really kind of fixed it up. I don't want to make it too bad at range, but I also don't want to make it so strong that you can reliably one-shot people from just about any range. So I think it's in a better spot. The balancing is going to be a big issue that I'm going to have to really go over a couple of times, and I think GDWC it'll be more in line with where I want it to be, but it's going to need a lot of playtesting, I think. So it's the initial balance phase, I guess. Enemy voice progress, so voicing some of the enemies so that we can get rid of just placeholder sounds. And not super happy with them, but you know, I guess it's a more advanced placeholder. It's a better sounding placeholder because before, when an enemy would die, it would just play a broken glass sound effect. So I guess a bad voice effect is way better than that. So definitely going to be messing with that a little bit more. Tweaked giblets. Giblets are just an ongoing thing here because I really want that to feel good. That needs to feel really satisfying, and even still, it's not there. What I did was I added more gib sprites, and I also changed up the blood effect. Changed a few other things about it as well, so that now it's working a little bit better. It's closer to where I want it to be, but definitely not there yet. Added SR40 into the game, which for people who do not know, SR40 is it's mostly a speedrunning term. It stands for Strafe Run 40. It's originally from Doom, where if you move diagonally, then you move faster. It was originally a bug with acceleration with movement, but I didn't have to add the bug in. I had to just add the functionality in here. So it's kind of a fake SR40. But for me, these types of games don't really feel right without it. So one of the things about the game that I kind of I wasn't entirely sure on was movement mechanics. I knew that I wanted a little bit more advanced movement into the game than just running forward and backwards and strafing. And so originally, the idea was to have a dash or a blink, a little teleport in the game. And that was in my first phase of testing, but people kind of had their mixed opinions on which one they preferred. And I noticed that as I tested the game, I never used them. And I figured if I never used them, then most other people wouldn't. The original idea was to be able to use it as a gap closer or an escape in case you ever had to use melee. And I don't really feel like that's entirely necessary right now. So rather than have a useless feature, I decided to add in SR40. And for people who don't use that, I also went in and in the game you have 2 injectors for adrenaline. That's basically a portable heal. And what I did was I originally had a little bit of a speed boost with them. But it was a small percentage, but still a faster speed boost. But what I did now was, since there's no dash or blink anymore, I decided to boost the speed boost on the adrenaline. So now you've got a little bit more movement option worked in there as well, in case you don't use SR40. Or if you do, SR40 does scale with that speed boost. So speedrunners, have fun with that. Next, main character voice progress. I'm working on getting a voice for the main character, and should hopefully have that in before GDWC. Not going to be getting in all the lines that he's going to be having, since, obviously the game's not done yet, but some initial lines and a good feel for the character. So I'm looking forward to that. A keypad and door integration. That is coded in a keypad that you type a code into, and then it will unlock a door that it's bound to. And so I'll go in and actually show you guys that, because that one was kind of fun for me. And then a door bug fix. The door bug fix was an issue with the save system that I had before. So before, when I would save the game and then you would load the game, I would have to account for doors that were already open. And so it would save things about doors, like if it had to save all their stats, but when they were open, it has a boolean to see if they're open or not. But when they were open, I had it set to where it would just put them at their normal open rotation, but it would also save their transform, which is their location, scale, and rotation all combined into one. And so what it would do is it would overwrite the transform as being open, and then it would basically open twice. If you would save with an open door and then load it, it would be like in the wall. So I had to adjust that a little bit. So got that fixed, so that's no longer an issue. So with that done, let's go into Unreal and talk about these keypads. Welcome back to the Unreal editor here. You can see we've got our door and our keypad here. Let's jump in and I'll show you the functionality. Let me spoil a secret here real fast so I can get my crosshair so I can hit the buttons. So, see, works just fine. And you can't interact with the door after that or before. So how does a keypad like this work? Just ignore the line trace debug there. So how does a keypad like this work? It's a very simple concept. You have a pad with buttons, press the use key on a button, and it activates if it's the right code. The line trace debug kind of spoils a little bit here, but if you don't really know much from the development side, then probably won't spoil that much. So anyway, let's get on into our keypad blueprint here, and we will see how it works. So first off, we're gonna go into the viewport, and you can see a little bit more about it here. So here we have got our collision box that is essentially saying if you are in range to interact with the keypad. Otherwise, if you just hit the interact button without being in here. If this didn't exist, then hitting the interact button would just start having you shooting line traces everywhere. You'd be always technically interacting with it. So we've got that. Go in here, and now we have the keypad itself. So what exactly makes up the keypad? We've got a cube, which is just there to add a little bit more mass to it. You don't need a lot, but I didn't want it to be flat. I wanted it to have a little bit more mass because it is something that's interactable. So I think it would be a little strange to have something a little bit more important that can open doors and have it just be flat and potentially blend in with the wall. So this way it'll stand out just a little bit more. We have got a light. The light is just to give it a little green glow and to also apply a red light if you get the code wrong. Then we have the sprite itself, and here you can see the keypad sprite is the root for this, so everything is bound to this sprite. That means if I resize this sprite, then everything else will resize with it. That's just nice from a development standpoint. So now we've got our, as you see, button 5, button 6, button 7. So those, this is actually all one sprite. But how do we divide the buttons up if they're all in the same picture? And the way that you do that is you create little collision boxes that are the size of the buttons. So we've got a collision box for every one of these buttons. Then we have got display 1, display 2, display 3, display 4. These are, right now, they're invisible, but they are sprites that go right over these lines. So as you saw, these are your number sprites. So we know what makes up the keypad. We just need collision boxes and some sprites. Going to our construction graph here, this is, if you do not remember, this will run as soon as something is placed in the editor. It does not need the game to be currently running for this to be executing. That way, as soon as an object exists, this takes place. It's just useful if you know something always needs to be the same with the game, or if you need something to essentially execute before any running code does. So that way you can build functionality in early. So what we are doing here is we are adding our button collision boxes into an array. So we're basically just making a list of all of our little collision boxes for our buttons. And then we are setting a variable that is the starting green light for the light color. And that's just so that we can guarantee that we go back to the same color after, if someone enters in the code wrong, then it'll go back to the same color. So here, now, go to our begin play. This is what will run as soon as the game starts with this in the level. So begin play, well, really as soon as this actor exists, which it's placed in the level. It doesn't get spawned in by like pressing a button or anything. So if we spawned it in by pressing a button, then it would run as soon as we spawned it in, but this just runs at the level start since it's already there at the start of the level. Got our begin play. We will enable input for the player controller and set a player reference. This is just making it so that the player is able to interact with it and it knows to listen for player inputs. And then here we got our enhanced input action interact, which is just pressing your use key. And then underneath here, well, here we've got a gate. So that pressing the use key enters this gate, and that is just, it's like it sounds, a gate. You can open it to go through, or you can close it to block things from going through. So it starts closed, so you open it by on component begin overlap with our collision box. That means that, so other actor equals our player reference. So that means if the player is overlapping our collision box, this guy here, then you can open the gate. And then when the player ends overlap with the collision box, then it closes it again. Now we've got a do once node here with a reset buttons event so that can reset the do once node. Because if, for instance, we pressed a button and we didn't have a reset, then we could only ever enter in one button to the keypad. So we need to make sure that we have a way of resetting this do once. And the reason I put a do once in there is so that you can't just kind of spam inputs, and so that you can lock off inputs as you need to. All right, so from our do once node, we move on to a line trace for objects. A line trace that originates from the player's camera world location. So that is essentially just the center of your camera, which is where your crosshair is. So that's where you run line traces from anything that you really need to aim at. And then it ends about 150 units away from where your camera is. It doesn't need to be super long, but it doesn't matter if it's a little too long because line traces will end as soon as they hit an object that they're designed to hit. And what might that be? Our object types are vehicles. And I know that sounds a little strange. We are making a keypad, but we are setting a line trace to hit vehicles. In this game, in Unreal, you've got different object types: world static, world dynamic, pawn, physics body, vehicle, and destructible. And since I don't have vehicles in this game, I just use vehicle as an option for things that I don't want my important line trace to hit. The important line trace is your hit scan weapons. So I don't want you to be able to swing your hook and hit an invisible collision box, or try to shoot at somebody and have the bullet get stopped by a collision box. So I have that set up to ignore vehicles, and then I mark collision boxes as vehicles. But this line trace here is set up to hit vehicles. So what does that mean for us? That essentially just means that I am able to set up the keypad numbers as an object that I don't have to worry about in terms of, like, I don't have to worry about them getting shot, and I can just have them kind of be like their own line trace. Basically, because every time you shoot out a line trace and it hits something, it's still generating an overlap. And so I would just want to make sure that it's basically guaranteed not to hit anything else. It's only hitting vehicles, and there's not that many things that are tagged as vehicles. Then we have our button pressed event, which we send out the out hit component into. And this is a custom event where it gets a little messy here. I'm sure that there is a nicer looking way that I could have done this, but I made it as nice as I know how to. So I just try to follow along here. So we've got the out hit component, and we have to make that a component because the button collision boxes are collision components, because they're not actors, they are part of an actor, so they are a component. So we are only looking for what component we specifically hit. And so we are checking our list, our buttons list. You might remember that in our construction script, we made this list. So this list contains all of our button collision boxes, and we are seeing if the component that we hit is in that list. If it is, well, first, if it is not, then we just reset the line trace. So we go back and we reset this do once node. Otherwise, that would mean if you hit something that wasn't a button, you wouldn't be able to try to press buttons again. Now, if it is in that list, then we see first set, second set, third set. This is just saying if the number has been set in that slot. So first set, if it's the first button that you're pressing, then first set will be false. So if first set is false, then that means that you're entering your first number. And we go into our set number function here, which is our number sprites list. And you see we've got our list of sprites here, 0, 1, 2, 3, 4, 0 through 9. And those are in the same order as our buttons. And what we do is it might be a little hard to see here, but we are feeding in the sprite component, which is the button sprite, the slot. So display 1 is the first number. We're feeding that through into here. And then the number. So this is from our list of buttons that you hit with the line trace. And you're saying, so if the line trace hit collision box for button 4, then we'll see button 4, that is fourth in the list. We feed that through. So number 4, number sprite 4, we're feeding that number through. And that lines up with the fourth sprite. So that will set the sprite for display 1 to, in this instance, 4 for the sprite, and then it will play a little beep. Then it will go on and it will set a variable to just the number, so number 4, so set number 1 to 4, and it will then mark first set as true, and then it will reset the button. So that repeats. As you see, we set first set to be true, so then that moves on to second set, which would then move on to third set, and then our final set here. So we would have all of our numbers set, and then when we have all these set, we go into a branch, and then we format this text to show the first number, the second number, the third number, and the fourth number, and then we check against our preset code. So in this instance, it's 1, 2, 3, 4, but we go into the editor, I select the keypad, you see I could change that to whatever I want. And as long as it's 4 numbers, it'll work correctly. So if that equals exact, then go in and get the actor location, will play a success beep. Then it will get all the actors with the tag uses keypad, which is just going to be one door. I'm not going to have a level that needs a whole bunch of doors with a bunch of different codes. If I could set that up to be like this, but I would need to then go in and set groups to the doors and the keypads. I didn't put that in here because if I started doing that, then I would need to start messing with the code a little bit more for the keypad and the doors, and then alter some of the save data. So this way, it's simple and it works just fine for what we need. So then that opens door. That is target is iKeypad. So that's just an interface that single door and keypad both use. So essentially that has the door code listening for when this is activated, and this will call to activate this, which will make the door code run the code that's associated with this. But if your code does not equal the code that's set for the door, then you get a red light, a little bit of a delay, and then it resets the light color and then resets the keypad so you can keep trying. I am kind of considering something, adding a little special something in for if people just start spamming codes in and they get a certain amount wrong and a certain amount, then you can do something like an explosion or something. But I'll worry about that later. And then our reset keypad code is just setting everything back to default. It's setting all the numbers back to blank, resetting all these set numbers to false, and then running reset buttons, which is just opening up our do once node again. Now we have our door code here, and we've got our event open door, so that is when that event gets called when you enter in the correct code. We've got a branch here checking to see if the keypad is saying that the door should be open. Really, this is redundant because this isn't being called ever unless the door is being called to open. But it's kind of just future proofing, just in case. Like, I don't know, maybe there could be a scenario where I want to call the door to close, like have the keypad close doors. So that way I could say if is open is false, then I could go here and have it close the doors instead. So that's just adding that in, just in the rare event that in the future I decide to have it be able to close doors as well for whatever reason. Then we are checking to see if the door is already open. If the door is already open, we do not want it to open again, otherwise it'll start clipping into walls and I guess could potentially wrap all the way back around and shut itself again. So it's just, make sure that we can only do it once. And this is mainly here for save loading, because if you save the game while the door is open and then load it, then you'd be able to interact with the keypad again, and you could potentially reopen or re-enter the correct code, which would then call to open the door again. So we need to make sure that we save if it's open or not. So if it is not open already, then it will open. So it's pretty simple for the door. So then, that is really it for the keypad. So we go in. We are inside the collision box. And then, let's say we enter the wrong code. It doesn't open. Can't open the door normally. See the line trace. When it turns green, that means that it's hit something. So you can see even where that dot is. You can see where it's hitting the button's collision boxes. We try again. Got the code correct, and it opens the door. What if it doesn't open it twice? So it works perfectly. And that is how a keypad can work. I'm sure that there are other ways of doing it, but this seems to be a very simple and effective way that works just fine for me. And I'm very, very happy with how smoothly it went making it. So just a little something, not necessarily to show off my coding skills to you guys, because that's it's not exactly all that impressive, but something to kind of show you kind of what goes into developing something simple in a game, kind of like the elevators. Thankfully, this was nowhere near as complex as the elevators, but still, give you a little bit more of an idea of how games work. So that is it for this update. I will see you guys next month. Thank you very much for watching. Make sure you go follow the Twitter and join the Discord if you are interested in seeing how the GDWC is coming along, and still posting some updates now and then to the Twitter account, but it's a little slow to show things off without spoiling everything. So it's slowed down a little bit, but it's there for live updates. So follow if you want. Thank you for watching. I will see you guys next month. Have a good one, everyone.